friends. We're here today to learn about the commutative property of multiplication. We've already learned about the commutative property of addition because in this commutative, we wear flip-flops. That just means when you're adding, you can flip the two add-ins in any order and you're still going to get the same sum. Well, the commutative property works the same way with multiplication. It says that you can flip the factors any way and you'll still get the same product. So let's do a couple examples. It says write a multiplication sentence for the array. So we're going to get our pen ready and we're going to write a couple of multiplication sentences here. Okay? So this multiplication sentence, the first factor is going to be how many rows I have. I have 2 rows, so my first factor is 2. My second factor is how many in each row, so I'm going to count 1, 2, 3, 4, 5, 6. I have 6 in each row, so my second factor is 6. And I'm going to count what I have total to get my product. 2, 4, 6, 8, 10, 12. My product is 12. Now, let's look over here at this array. This is a very similar array. It's just turned up on its side. So let's find out what our first factor is going to be. Our first factor is how many rows. So I have 1, 2, 3, 4, 5, 6. I have 6 rows. My second factor is going to be how many in each row. I have 1, 2. I have 2 in each row. And my total number is going to be 6, 12. So I realized by making arrays that I have 2 times 6 is equal to 12, but also 6 times 2 is equal to 12. That's the commutative property of multiplication. We can actually write it like this. We can write, well, not that fat of a marker. We can write 2 times 6 is equal to, notice I use the equal sign, 6 times 2. That's just saying that 2 times 6 is the same thing as 6 times 2. That's the commutative property. All right, let's scroll down a little bit here and let's look at these. It says, write a multiplication sentence for the model, then use the commutative property of multiplication to write a related multiplication sentence. Okay, so my first multiplication sentence, it has to match this model. My first factor is always going to be the number of groups. I have 2 groups. Make that marker a little bit skinnier. Okay, 2 groups, 1, 2. My second factor is how many in each group. So I have 1, 2, 3, 4 in each group. Okay, my product is how much total. So I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 total. Now, to show a related multiplication sentence, what I'm going to do is I'm going to flip-flop the factors to show the commutative property. So I've got 4 times 2 also equals 8. Okay? Let's try this one. I've got to find my multiplication sentence, so the first factor is always going to be my number of rows. So let's count the rows. 1, 2, 3, 4, 5. I have 5 rows. Okay? My second factor is, well, how many are in each row? So 1, 2, 3. There's 3 in each row. My product is how many total? That's 5, 10, 15. It's going to be 15 tiles total. Well, to show the commutative property, I flip-flop the factors, and instead of 5 times 3 is 15, I do 3 times 5 equals 15. Okay? Let's do one more. First, my first factor is the number of rows, so I have 1, 2, 3, 4 rows. My second factor is how many in each row. I have 1, 2, 3, 4, 5. I have 5 in each row. Okay. Total, I have 4, 8, 12, 16, 20 total. To show the commutative property, I just flip-flop my factors, and instead of 4 times 5, I do 5 times 4. It's also 20. Okay. So another way I can write this is I can say 4 times 5 is equal to 5 times 4. I'm saying this side is equal to this side. All right, I'm going to show you something else. Let me switch over to a different screen here. Okay, look at this screen. Let's say I had to work with the commutative property, and let's say they gave me a problem like this. Let's say they gave me 3 times 2 is equal to 2 times 3. Well, this is the commutative property because look, it's saying 3 times 2 is equal to or the same as 2 times 3. And it is equal to or the same because this 3 times 2 is 6. But guess what? 2 times 3 is also 6. So this is a true statement. But sometimes they are going to see if you can figure out a missing factor using the commutative property. For example, let's say instead of giving you this problem up here, they gave you 3 times 2 equals blank times 3. Let's say that they left that blank and said, using the commutative property, what number do you know has to go here? Okay. Well, I know that all I'm doing is flip-flopping the factors. So it looks like they flip-flopped the 3, but they've left out the 2. So I know that the factor that should be in this blank is a 2. Okay, and then I have completed 3 times 2 equals 2 times 3. Let's try another one with different numbers. Let's try the numbers 6 times 2 equals blank times 6. And let's use the commutative property to figure out what's missing. Okay, well, I can see that they flipped my 6 because there's the 6, but look, they did not flip my 2. So I know the missing blank has to be the 2 to show the commutative property. Now I've got 6 times 2 is equal to 2 times 6, and that's correct. Okay? And sometimes it won't be a blank. Sometimes it'll ask you to find maybe the square. So it might look like this. 1 times 10 is equal to 10 times, and let me see if I can put a little square in there. I think I can. 10 times square. And it's saying, okay, can you figure out what this square is supposed to be using the commutative property? Well, I'm glad you asked. I can, because look, they flipped the 10. What's the other factor that they forgot to flip? They forgot the 1. Yeah, so you know square has to equal 1. Square is equal to 1, meaning that I could put a 1 here and then it would be correct. 1 times 10 is equal to 10 times 1. Okay? All right, guys, you all use the commutative property to solve multiplication equations today. So remember, in this commutative, we wear flip-flops. Great job, friends.